Today we're going to talk about square roots. So let's review what it means to square something. Let's say we want to evaluate 3 squared. That means just that we're going to multiply 3 by itself. So 3 times 3, which is 9. Now let's get the definition of square root. The square root is the inverse of squaring something, just like addition is the inverse of subtraction. So the square root of a number, in this case, we're just going to say x. So the square root of x is a number whose product, when multiplied by itself, is x. So, for example, 9 squared, which is 9 times 9, is 81. However, if we do negative 9 squared, that becomes negative 9 times negative 9 is also 81. But if we do negative 9 squared without the parentheses, that's really saying negative parentheses 9 squared, which is negative 81. So be very careful when you're looking at what you're squaring. So when we want the square root of 81, we want two numbers that when we multiply them together, we get 81. So that would be 9. If we want the negative square root of 81, that would be negative 9, because the square root of 81 is 9, and then we'll put the negative. If we have the square root of negative 81, we can say it does not exist in the real number system, because there are no two numbers that we can multiply together that they're the same number that will give us negative 81. If we multiply 9 times negative 9, we'll get negative 81. However, the definition of the square root is that it's a number multiplied by itself. So anytime you get the square root of a negative number, it does not exist in the real number system. So let's do an example. Find the square root of 25. So a number that we can multiply by itself that will get us 25. That would be 5. What about negative square root of 49? So a number that we multiply by itself, we can get 49. That would be 7, but we do have the negative in front, so it'll become negative 7. We want to state whether the square root of 144 is an integer, a real number, or not real. So in order to determine if it is an integer or a real number, we know that it's not going to be not real because it's a positive number inside the square root symbol. So we just need to determine, is it an integer or is it real? So we have to decide, is there a number that we can multiply by itself to get 144? Well, that would be 12. So because there's an actual whole number that we can multiply by itself to get 144, we can say that the square root of 144 is an integer. What about the square root of 132? Now, there is not a number that we can multiply by itself to get 132. However, it's not negative, so you know it has to be real. Square root of negative 36. Since there's a negative inside the radical symbol, we can say it's not real. So here is a list of what we call perfect squares. You are going to need to memorize all 20 of these perfect squares, and you're going to have to know it both ways. For example, you're going to need to know that 14 squared is 196. However, you're also going to need to know that the square root of 196 is 14. You're going to have a quiz over these, so make sure that you study. So these are called perfect squares. The square root of 16 is 4, which can be rewritten as 4 over 1, which means it is a rational number. So what if x is not a perfect square? Then that means that the square root of x is an irrational number. For example, the square root of 5. If we were to put the square root of 5 in our calculator, it would give us a decimal, 2.2360, and so on and so on and so on. It's an approximate number. It's not actually the exact number. It's just an approximation. So we can estimate the square root of x by finding two perfect squares between x lies. So that's why it's so important to memorize those 20 perfect squares so that way you can use them to estimate. So let's do an example. Let's find two consecutive integers that's the square root of 32 lies between. So I know that 36 is a perfect square, and I know that 25 is a perfect square. So that means that the square root of 32 is between 5 and 6. So let's do the guess and check method for the square root of 19. I know that 25 is a perfect square, and I know that 16 is a perfect square, which means that the square root of 19 is between 4 and 5. We can actually take it even further. Let's go ahead and estimate that the square root of 19 is 4.2. By the definition of square root, that means that 14.2 squared should be 19. But if I do 4.2 squared, I get 17.64, which is way off. So why don't we try doing another tenth? Let's try 4.3. Well, 4.3 squared gives me 18.49, which is a little closer to 19. So let's do 4.4. 4.4 squared gives me 19.36, which is a little bit over 19. So notice that when I did 4.3, I was off by 0.51. And when I did 4.4 squared, I was off by 0.36. So since 4.4 got me closer to 19 than 4.3 did, my approximation for the square root of 19 is going to be 4.4. Let's try another one like that. Let's do the square root of 47. So I know that 49 is a perfect square, and I know that 36 is a perfect square, which means that the square root of 47 is between 6 and 7. So I just need to narrow it down. Let's start with 6.9. 6.9 squared is 47.61. That's 0.61 off from 47. So let's see if we can get closer. Let's try 6.8 squared. When I do that, I get 46.24, which is off by 0.76. So since 6.9 got me closer to 47 than 6.8 did, the approximate answer for the square root of 47 is going to be 6.9. All right, let's estimate the square root of 53 by finding two consecutive integers that lies between it. Go ahead and try this one on your own and see if you can get the correct answer. You should have got that the square root of 53 was between 7 and 8. Let's talk about this rule. Let's say we have the square root of x plus the square root of y. In this example, we want to simplify each square root before we add. However, if we have the square root of x plus y, we're actually going to want to add x and y first and then simplify by taking the square root. So let's look at this example. The square root of 64 plus the square root of 25. We're actually going to want to do the square roots first before we add. So the square root of 64 is 8, and the square root of 25 is 5. So it becomes 8 plus 5, which is 13. Now let's try the square root of 72 minus 23. So notice that the subtraction is actually inside the radical, which means that we want to subtract first and then take the square root. So 72 minus 23 is 49, and the square root of 49 is 7. So for this one, notice there's a negative 4 on the outside. So we're going to multiply after we take the square root, but we can't take the square root until we subtract. So you're going to work from the inside out. 116 minus 35 is 81. And then the square root of 81 is 9. And then negative 4 times 9 is negative 36.